In the previous video, we're able to prove that two lines are parallel given the relationship of the pairs of angles when two parallel lines are cut by a transversal. This time, let's do the converse. Okay, so let's start by this theorem. If two lines are cut by a transversal so that two corresponding angles are congruent, then these lines are parallel. So let's show that this is true. But first, let's illustrate our theorem using our figure. Okay. So let's suppose that we have line A and line B cut by a transversal C, and let's name the angles as angle 1, 2, 3, 4, 5, 6, 7, and 8. Given, according to our hypothesis, is that let's say angle 2 is congruent to angle 6, because we know that angle 2 and angle 6 are corresponding angles. So what we are to prove is the conclusion part, which is let's prove that line A is parallel to line B. Okay, let's have our proof. So again, let's write our proof in two column format, which we have the statements and we have our reasons. So for number 1, we know that it always starts with a given. We have angle 2 is congruent to angle 6, and it's always given. Next, number 2. So what information can we obtain from our given figure? We can see that angle 2 is congruent to angle 3 because they are vertical angles. So let's write that one. Angle 2 is congruent to angle 3. And the reason is the vertical angles theorem. Okay? And of course, it's obvious already that angle 6 is congruent to angle 3 by the transitive property of congruency. And therefore, since angle 6 is congruent to angle 3, and we know that angle 6 and angle 3 are alternate interior angles, then we can say that we can therefore conclude that line A is parallel to line B. And the reason is, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. And this ends our proof. Okay? The next theorem. Next theorem says, if two lines are cut by a transversal so that two alternate interior angles are congruent, then these lines are parallel. So again, let's illustrate first. Let's say that let's have line A and line B again cut by a transversal C. And let's name the angles as 1, 2, 3, 4, 5, 6, 7, 8. Okay, so given according to the hypothesis is that angle 4 is congruent to angle 6 because we know that angle 4 and angle 6 are alternate interior angles. And what we are trying to prove is that line A is parallel to line B. Okay? Let us have again our proof. So, having our statements and reasons. So, for number 1, again, angle 4 is congruent to angle 6. And the reason is given. For the second statement, let's take a look at our given figure. Okay, we know that angle 4 and angle 2 are vertical angles. So therefore, we can say that angle 4 is congruent to angle 2 because that is the vertical angles theorem. And again, it's obvious that we have angle 6 congruent to angle 2. That is by PPC. And therefore, we can now conclude that line A is parallel to line B because we know that from the given figure, angle 6 and angle 2 are corresponding angles. So, we can write this one as if two parallel lines are congruent, then the corresponding angles are congruent. Okay? That ends our proof for this theorem. Next, if two lines are cut by a transversal so that two alternate exterior angles are congruent, then these lines are parallel. So actually the proof of this theorem is similar to that of the previous theorem. So you just need to um, plug in the angles that you want following the justifications. Okay, so but I will write in here in the previous figure. We're going to use the same figure since, okay, let's say angle 1 and angle 7. Since angle 1 is congruent to angle 7, okay, then we can say that it follows that line A is parallel to line B. Okay, that's according to the theorem. Let's have an example. In figure 2.18, which lines must be parallel if angle 3 is congruent to angle 8? Take note that we have here angle 3 and angle 8. So we have here angle 3 is the exterior angle of line C when it is cut by B. Okay, as well as angle 8 is also an exterior angle of line B cut by line B. And we can see here that line or angle 3 is an alternate angle 3 and angle 8 are alternate exterior angles of line C and line B cut by line B. So therefore, we can say that the lines that must be parallel must be line C and line D. Okay? Or that is line C must be parallel to line B. Another example, using the same figure, the measure of angle 3 is 94. Find the measure of angle 5 so that C is parallel to D, or line C is parallel to D. We already know that the measure of angle 3 is 94. Okay? So, we can say that angle 3 and angle 5 are corresponding angles, correct? So we can say that since angle 3 and angle 5 are corresponding angles, then angle 3 is congruent to angle 5, and the measure of angle 3 is equal to the measure of angle 5 by the definition of congruent angles. Hence, we can say that the measure of angle 5 is equal to 94 by substitution. Okay? Next, if two lines are cut by a transversal so that two interior angles on the same side of the transversal are supplementary, then these lines are parallel. So again, let's illustrate it. Suppose that we have lines A and B cut by C, and let's name this one, the angles as 1, 2, 3, 4, 5, 6, 7, 8. You just need to name two interior angles on the same side of the transversal. So in this case, let's suppose angle 4 and angle 5. So angle 4 and angle 5 are supplementary. Okay? So if they are supplementary, let's show that line A is parallel to line B. So let's have our proof, our statements, and our reasons. So for number 1, we have angle 4 and angle 5 are supplementary. Okay? And we know that this one is given. So what do you know about, what is your knowledge when angle 4 and angle 5 are supplementary? can say that the measure of angle 4 plus the measure of angle 5 is equal to 180. Okay, and this is definition of supplementary angles. Now, so let's look at our given figure. So we can see as well that we already have angle 4 and angle 5 as supplementary. We can also say that angle 4 and angle 3 are supplementary because they form a linear pair. So from the given figure, we can say that angle 4 and angle 3 form a linear pair. This is figure. And number 4, since we know that they are linear pair, angle 4 and angle 3, then the measure of angle 4 plus the measure of angle 3 is equal to 180. And this one is definition of linear pair. And since we know that they are linear pair, our fifth statement will come from statement number 2 and statement number 4. So we have the measure of angle 4 plus the measure of angle 5 is equal to the measure of angle 4 plus the measure of angle 3. And this one is transitive property. Okay? Next. So, we can see that there is a common quantity in the statement number 5. And what we need to do is to subtract both sides of the equation by the measure of angle 4. So subtracting both sides by the measure of angle 4, if I will subtract this by the measure of angle 4, and I'll subtract this one by the measure of angle 4, then what will remain is the measure of angle 5 is equal to the measure of angle 4, which is subtraction property of equality. Okay, we are almost done. So for number 7, since the measure of angle 5 is already equal, sorry, it's not angle 4, it should be angle 3. Okay, it should be angle 3. So since they are already equal, we can say that angle 5 is congruent to angle 3. Okay, and the reason is definition of congruent angles, and therefore we can conclude that we can see that angle 5 and angle 3 are alternate interior angles. And since they are alternate interior angles, therefore we can conclude that angle A is parallel, line A rather, is parallel to line B, because if two lines or two parallel lines, let me correct that, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Then our proof is already done. Okay, let's proceed with the next theorem. If two lines are cut by a transversal so that two exterior angles on the same side of the transversal are supplementary, then the lines are parallel. The proof again is similar to the previous theorem, so we'll no longer show how it is being proved. But if you would like to prove this theorem, you can use this theorem as a pattern, or this proof as a pattern for the proof of this theorem. But in this case, I'll just write in the given figure so that it will not waste our time. Okay, in the given figure, I can say that let's say angle 2 and angle 8. Angle 2, two exterior angles on the same side. So let's say angle 2 and angle 7 are supplementary. Okay, then line A is parallel to line B. Okay. Another theorem that we should be reminded of is if two lines are each parallel to a third line, then these lines are parallel to each other. So this one is actually uh, proved using transitive property, but I'll no longer show it to you. I will just illustrate it. Let's say this one is line A, line B, and line C. And let's have a transversal. Let's name this as line D. Now, so according to the theorem, if line A is parallel to line B and line B is parallel to line C, then we say that line A is parallel to line C, okay, by transitivity. Okay, so you have to take note of this theorem because we're going to use that one later as well. Okay, next. Another theorem will no longer prove this. If two coplanar lines are each perpendicular to a third line, then these lines are parallel. So to illustrate that one, this is actually an extension of the previous theorem. So you can prove this theorem using the previous theorem if you want to explore. Okay? So let line A, line B, and line C, and line D. And let's have the symbol for perpendicularity, because according to the hypothesis that um, the transversal is perpendicular to the lines. So if line D is perpendicular to line A and line D is perpendicular to line B, also line D is perpendicular to line C. Now, okay, let's remove the word if. Let's suppose. Okay, let's use the word suppose. Okay, if line A is parallel to line B and line B is parallel to line C, then line A is parallel to line C. That is the theorem all about. Okay? Let's have an example. So given that the measure of angle 1 is equal to 7x and the measure of angle 2 is 5x, find the value of x so that line L will be parallel to M. Okay, so let's have our solution here. We know that angle 1 and angle 2 are interior angles on the same side of the transversal. Okay, and since they are interior angles on the same side of the transversal, this implies that the measure of angle 1, I'm about to take my meds. Measure of angle 1 plus the measure of angle 2 is equal to 180. Okay, so by substitution, we know that this implies that we have 7x plus 5x is equal to 180. Combining similar terms, this implies that we have 12x is equal to 180. So that dividing both sides by 12, therefore we can say that x is equal to 15. Now, so the measure of angle 7 to check, the measure of angle 1 is equal to 7x, which is whenever x is equal to 15, so 7 times 15 is 105, and the measure of angle 2 is equal to 5x. Then we have 5 times 15 is 75, and the measure of angle 1 plus the measure of angle 2, A is equal to 105 plus 75, which is 180, and therefore our answer is correct. Okay, in the next video we'll talk about the angles of a triangle.